student, today we will learn the chapter Maxima and Minima. In this part, I am describing about application of Maxima and Minima. As in the previous part, I have described something about this topic. Now I am going to define it once more with the help of some questions. Now, differential calculus, we have already learned how we got the higher order D2, D3 to find the maximum values and minimum values. Okay. So here is a method we will use. Step 1, that is, frame the functions in terms of variables. Frame the function in terms of variables. What we have learned here, when we'll do the sum, then you will be understand this more. Variable may be 2 or more depending upon the data as given in the questions. You have to first frame a functions in one or more variable. Okay. And step 2, with the help of the given conditions, express the function in terms of one convenient variable by eliminating all other variables. Okay. Now step 3. Now find first derivative and apply conditions of maxima and minima. Okay. Now I am going to tell you how you can understand this language. Let you have a functions k equal to xy square. Here k is constant. Okay. X, y variable. I am taking this just for an example. Now you want to find a equal to x square plus y. You want to find a either maximum or minimum. Now this way you have to always find any two equations. Here is some example only. One equation will be in a constant and one equation in this variable will be for finding maximum or minimum value. Then if here one or more variable, you have to take any one variable here using these equations. Let if you want to find in terms of here x, so you have to relate it y. If you want to find in terms of y, you have to left it x using this. Okay, for example, if we put here value of x, k upon y square whole square plus y. Now this is your equations. Okay, if you want to find in terms of x, then you can put here x square plus value of y is k upon x under root. So this is your equation. So any equation you can find out which will be easier for you. If you want to take in y terms, you can take in y terms. If you want to take in x terms, you can take in x terms. Now using these equations, for what value of x you find the minimum value and maximum value of a. Okay, right, as using the first derivative or higher derivative, whatever the formula you want to be use it. Okay, and now second thing is, if it is given y equal to 10x plus sec x, let us as example. So here we can see differential of this step is easier rather than differential of this one. Now if this question is given and you want to find derivative of these functions for maximum and minimum value only, and so it is easier. Now if the question is this one is given, so you should be take this way, let p equal to y square 10x plus sec x. Now for using this function, if p is maximum, then y is maximum. Okay, if p is minimum, then y is minimum, maximum or minimum, then it is also minimum. And now here I have already explained in questions in the previous video, it is reciprocal of this. If we take z equal to 1 upon y equal to 10x plus sec x, now it is easy. Now here you can say easy, since it is easy to take the differential. So if z is minimum, then y is maximum. Okay, if z is maximum, then y is minimum. Okay, so using these two concept, anywhere if you use this concept, then you can take the equation in this form. Okay, so differential will be easier for you. Now again, if you taking the square or cubing here, if p is maximum, then y is maximum, p is minimum, then y is also minimum. But in the reciprocal case, if z is minimum, then y is maximum, if z is maximum, then y is minimum. Use these steps for finding the maximum minimum value for dy by dx or d2y by dx square. Okay, so when you take this question in this form, then differential will be easy for you, right? Now I am doing here some questions now. Before informing the questions, I will tell you the question may be regarding with the plane or solid. Okay, so you should be know the all formulas, basic formulas regarding that: square, triangle, circle, and in solid, cube, cuboid, and cylinder. If you don't know all this formula, you should be go to their chapters separately given in the previous video. You have to check the in previous list. Okay, so now I am going to tell you a questions here. Find two positive numbers numbers whose sum is 20 and whose product is as large as possible. Okay, so you can see here as large as possible. Whenever you find this type of the language, as large as possible, as minimum, maximum, it is related question with maximum and minimum. As large as possible means maximum value you have to find. Okay, let two numbers are x and y, hence 20 equal to x plus y. Sum of two number is 20 and their product is x into y. Equation 1, equation 2. As in I have already explained, you have to make frame questions relating with two equations relating the given data. One should be in a constant and here you have to find the maximum value. Okay, for what numbers their product will be maximum. So this will is keeping as constant and these are two variables and these are two variables, and for p product should be large or maximum. Okay, so using these two equations we have to take in one variable. So we can write here, let we want to be change y, so we can write 20 minus x from this. If you want to be change x, you can want to be change x, and even it will be easier for you for x, then you can find x, put x, or if you it be easier for y, you can take the y. So now here these equations in one variable. Now this is your required equations. Now using the all basic concept, dp by dx is 20 into 1 minus 2x equal to 20 minus 2x. Okay, now dp by dx equal to 0, hence 20 minus 2x equal to 0, we get 20 equal to 2x, therefore x equal to 10. Okay, now d2p by dx square, what we got, 0 minus 2 into 1 equal to minus 2. At x equal to 10, it is equal to minus 2. Putting here 10, now you have to write this. Here x is not here, but we can see that value of x is here, then the power of x is 0. Power of x is 0. So putting here 10 to power 0 means 1, means it is minus 2. So you have to write this. At x equal to 10, d2p by dx square is minus 2. Minus 2 means less than 0, means negative. When it is negative, so we can say at x equal to 10, our function p is maximum. Hence, at x equal to 10, p is maximum. Okay, so since y equal to 20 minus x, 20 minus 10 equal to 10, hence x equal to 10, y equal to 10, two part of 20 are 10 and 10. And in our questions, find two positive numbers whose sum is 20 and whose product is as large as possible. So two numbers are 20, which sum is are 20, two numbers are 10 and 10. Okay. If we want to find the largest value of p, then P equal to X into Y, 10 into 10 equal to 100. So 20 is divided into two parts, 10 and 10, so that two numbers are 10 and 10. Answer, two numbers are 10 and 10. Okay, understand this question. Now student, I am telling you one more questions. The length of the perimeter of a sector is 20 centimeter. Give an expression for the area of the sector in terms of R where R is the radius of circle. Okay, and hence find the maximum area of the sector. And student, you know that in a circle radius R here, the length of the perimeter of a sector is 20 centimeter. Give an expression for the area of the sector so that of R and in terms of R, and hence find the maximum area of the sector. And let this one is sector, radius is R, let this angle is theta. Let this arc is L O, sector A O B A. Okay, perimeter of sector, perimeter of sector is AO plus OB plus BA equal to R plus L equal to 2R plus L. Okay, and it is given 20. Perimeter of the sector is given 20, right? Now, since we know arc equal to angle theta upon radius, so L equal to theta upon R, right? So now you know area of sector is half R square theta. How we can got it? Theta upon now we can change theta, we can write here L upon R. This one is R into arc. Theta equal to L R. Theta equal to L upon R. Okay. Now, using this, we can find half RL. And changing in one variable using these equations, from this equation, L equal to 20 minus 2R. If we want to put or R equal to 20 minus L upon 2, that also can be put. So we are changing it L, 20 minus 2R. Now it is in one variable your required equations. Okay. So it we can be write 10R minus R square. Now using this equation we can find dA by dr, 10 into 1 minus 2R equal to minus 20R, right? Now dy by dx equal to 0, 10 minus 20R equal to 0, so that we can get ten into 1 minus 2R, 10 minus 2R. Now 10 equal to 2R, so R equal to 5. d2y by dx square, d2y by dr square is equal to 0 minus 2 into 1 equal to minus 2. At R equal to 5, it is minus 2 less than 0. Hence at R equal to 5, area is maximum. Okay. And if you want to find the maximum area, so maximum area you can find it in the given equation, that is 10R minus R square, 10R minus R square, 10 into 5 minus 5 square, 50 minus 25 equal to 25 centimeter square. It is your required answer. Okay student, this will be helpful for you to solving some questions. In the next video I will do some more questions on using solid or plane. Okay, thank you.